All right, testing, testing. All right, testing, testing. How's the keyboard? Damn, that's loud. All right, all right. If anybody in the chat is around, say hello and let me know what you're interested in. But I need to do some refactoring of the eval system, which is the thing that basically decides, given a specific parse, what we're going to put in this response field. Okay. So right now, oh yeah, that's a good point. How is that? Let me know if that's big enough. I can't go quite as crazy large as on Wakash stream, I think, because that'll kill any hope of me working on large code, but sweet. All right. If anybody can't read it, let me know. So right now, not the problem I have, but right now, if you type something like, 4 times 4, it evaluates it. But if you type something like 4 times x, it doesn't know what x is, so it just sort of gives up. It really ought to write an error at the moment, but it just comes out nil. Cool. Glad you guys can see it. And what I'd like is, and so if you declare the variable, this is the syntax for adding a variable. You just use the colon. Then, it'll correctly evaluate the variable here. But if it doesn't know the variable, I really kind of want it to write 4 times x, because later on what I want it to do is, if you write something like this, it should replace that with like x times 32. So basically the idea is that it should simplify away everything that it can do and then leave the stuff it can do. The reason that's useful is because you can then do things like, 30 meters equals how many centimeters, and it ought to be able to deduce that, like, I know that part. Or you can do like 10 meters times 10 meters, and this ought to come out to 100 meters squared. So in order to start putting together terms and doing unit dimensional analysis, we need to start working with quantities that we don't understand, not just quantities that we do understand. So that's what I've been wanting to work on. But if that is too specific, I could do something else too. Because the other thing I need to do is replace the UI system eventually. But that would be like starting a whole new UI kind of from scratch. So it might be a little bit slow starting. And I'm only going to be working on this for maybe about an hour and a half today. So I'll start on the other thing, but let me know what y'all think. Okay. So I think I'm also coming back from vacation, so I actually forgot how a lot of this stuff actually works. So let's just throw something in there like next time. Let's just see what x comes out. So I think it comes out through calc run. Yeah. And it's going to call advance. And advance is going to push a symbol. So I'm assuming we're ending up in here. Yeah. So here it's saying, okay. Yeah, UI systems. Yeah, I kind of had a suspicion that might be the case. Okay. Well, maybe we will do it. Okay, so yeah, so basically it's getting the X value and then it's like, it doesn't have any kids. So then it tries to eval the variable. It attempts to do a lookup. The lookup fails. So then it just doesn't do anything. Just like, oh, it looks for a built-in constant. And then it, yeah, okay. And then it just pushes it. Okay. So here probably we could do a, how do we do errors again? Do we have errors here? Where do we do errors? Yeah, we don't want to do like add error. So here, basically, Visual Studio, what are you saying? Do we have unknown variable? Unknown function, unknown operator, unknown variable. So this will just be kind of a warm up. And node get token. Yeah, okay. Oh yeah. Changed. Visual Studio edit and continue can't handle when you change enums. It just borks out. So now if we type X, there we go. We should get error unknown variable X. Sweet. Okay. So yeah, so now if you just type in X. Okay, so that's cool because now we can do 4 times X and it just says unknown variable X. Okay, that's an improvement instead of just nilling out. Yeah, because before it was just pushing a nil and then crapping out. Okay, but what I really wanted to do is give the X back. And for that, we would actually have to have like a proper tree. Okay. It's like I can't. So if I go to, oh, that's annoying. So if I go to the chat, it jumps in there. How does that work then? That's kind of, ugh. So I've never actually streamed with OBS. So, but if you like open the stream chat, it jumps into the OBS. So what, I should just run the chat from here? Is that how I should do it? I guess that's how I do it. Sorry, y'all. This is really more of a test stream of will this be interesting and work? So let's see. How do people usually run the chat when they stream? Do you guys do it out of OBS or do you do it like on a separate window or something? Yeah, like the built-in OBS widget. If I jump to it, it like jumps my whole stream. Like it takes over, like the OBS just pops out, which means like, yeah, blows everything away. Yeah, OBS widgets seem to be kind of crap, or at least they're not designed for this. All right. Well, anyway, I'm also realizing I'm just like jumping straight in. So if people are interested in like an overview of how this whole thing works, I can do that as well. I don't know how many people are here just to like watch for programming, and how many people are here interested in the architecture of this thing. But basically there's like a Lexer chunk that eats through the tokens. So if I type like x times 10 plus 8, you can look. So this is like my test harness. So whenever, the shipped version just sort of shows this bit, which runs in a window during the harness. And then all this stuff is like the internals that I use to debug the calculator. And so usually I don't really care about the Lexer, but you can see the Lexer stream. So it's got like start of stream, symbol asterisk, blah, 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 end of stream. And that's like the input string. And then usually what I care about is the parsing. And here you can see it parsed it as addition coupled with multiplication, symbol, and there's like a parse string, and there's also a test suite that runs in the background. And this is kind of like the test window, which is an uglier version of this one. And so the problem right now is that after the parsing step, I get the abstract syntax tree, and then I feed it to what's called like the evaluator. And the evaluator is this basically virtual machine that has a bunch of different stacks. There's the trying to remember where everything lives in the code. Yeah, so there's like eval stacks, value stacks, scope stacks, and the actual calculation is like an instruction stack, a value stack, and a scope stack. The reason I split lexing and parsing, Valigo, is I don't know why I did it. I mean, honestly, just because it makes the files smaller. The grammar's pretty simple, yeah. So, just as a quick overview, you have your basic operations. You can also do like their basic arithmetic operations plus exponentiation and factorial. You can call functions. So there's like a function call syntax that's trivial, and then some built-in variables. Where it maybe gets a little bit, not complicated, but trickier is if you can define functions like that, and the way that works is the last statement of the function is what's returned, so you can put them on the same line or you can put them on different lines. And where it gets like a little bit more trickier is you can define nested functions. So like, y times x, and there's closures and scope, like lexical scoping, and also just like scoping in general. So like x is going to be accessible within G and things like that. So the parser's, a little bit trickier than the standard grammar. So it's not like just a pure calculator. But you can define functions and you can define variables. So you can do something like this, z equals sine of pi, and then you can type something like that. And so, or even, G is like some global variable, and then you have access to the global variable, the argument, the local variable within the outer scope, and then the global variable. So you, but you're not allowed to return anything by reference. So that simplifies things. So you always only return values, which means that I can basically, I don't have to support proper closures yet, because I don't allow functions to return. But if I did, then that would get nasty. So yeah, okay, I'm glad the multipass is justified. Yeah. And units are not currently in the grammar, but I've been thinking about units. I'm actually curious if anybody's done units. And at first, my idea was to make units sort of like suffixes. So if you do like 1024m, that would be 1024 meters. And if you did like 10 centimeters, I would sort of internally, I can, at the Lexer level, I wrote this, but I'm probably going to throw it out. But it's easy enough to parse a number and then look for suffixes and then say, these are my units. And then, figure out conversions and things like that. But it starts to get annoying if you want to, like, if you have complex units, like meters cubed per second or something, turns out you can actually still parse that, because as long as there's like no spaces, you just grab that string off the token and then feed that to the part, like a mini parse effectively, and then you get those things back out as symbols and you can parse out the units. But then you're doing like effectively little mini syntax trees on your units. Just like, oh, this is starting to feel like a bit of a double thing. So then I was like, you know what, this is messy. Really what's happening here is there's like an implicit multiply. So the first thing I did is I added support for implicit multiply for tokens that are together. So if you have like x equals 5, you can do 10x and it's going to work out to be 40. Here's the result down here in the test window. So I now have implicit multiplication for parses, and I also have implicit I don't even know what to call this, but like fraction combining. So if you have a space followed by another number, it's going to add those numbers, but only if they're a fraction, I believe. So if I do 4, if I do 4, 1, then it's like not that. But if you do 4.5, then it will actually treat this as a half. And so my high hopes is to like ultimately end up with like 4.5 feet plus 33 and 8/16 inches, and that should like deliver a correct result just in this form alone without any kind of shenanigans. The reason for that is because I do a bunch of woodworking and so I'm having to work with wood, which is often in inches at like suppliers, but I like to work in millimeters because I'm an engineer. So it'd be like handy to handle that. So yeah, like Valigo, you're saying naively do M3S instead of M3X cubed. Okay, so philosophically, this project is sort of like my exercising ground. So mostly what I'm trying to do, it's a useful tool, but in terms of like actually programming on it, I try to do the hard fun thing just because this is like my hobby thing. And I think of it as like, okay, let's flex and try to do interesting things. So I'm less concerned about the result and more about like how aesthetically pleasing the operation is. So because of that, I want to do the good thing rather than the easy pragmatic thing. So that's context. But the other thing is I don't think it scales to like complicated stuff very well. I think I forget which units, but I looked through like common units, and if you end up, so because you don't know if it's squared or if it's like 1 over S2, right? You can't tell if this is 1 over second squared or 1 over second squared. You can do it via precedence, but I'd rather be explicit. So because of all that, basically, and because of another reason, I decided that I think the correct formulation for units is that they're just variables that don't evaluate to anything. So when you write something like 10m, the parse should be like what it says, which is 10 followed by symbol m. And m, if it's like a base unit, won't evaluate to anything. And let's imagine there's just meters to start with. But then what you can do is you can do centimeters is equal to 0.01 meters. And then if you have that, then you can do something like this and it should, like this question mark syntax, eventually I'd like it to do the conversion into that unit. Or if you do 10 meters plus 10 centimeters, it should know this relation and then be able to convert the units. And then you can do other fun stuff, like this could be like Anton meters, and it's like 33 meters or something. And so you can just do 5 Anton M. And then, so I like that idea that the meters can be defined by the units can be defined by the user. And then also you can do unit analysis on them. And so you can do something like 10 meters times 10 centimeters, which is actually legitimately useful. Sometimes you have a big old piece of wood and you're like, oh, it's 8 feet by like 13 millimeters or something, or like that. And so it's handy because I want to run this thing on my phone and basically be able to do calculations at like the lumber yard or something. So this is kind of a bizarre project because on the one hand, I use this for like work and game development where I use it for programming. And on the other hand, I use it for woodworking and random crap. Could we do 4 times 10x over 17 containing the I don't know what that would mean. So 4 10x divided by 17. Yeah, so it's going to say unexpected number 10. And I think that's correct because I don't think this is like a standard math notation. Like you ought to be able to do this, I think. Or if you want it to be, yeah. But putting the x here, I think is a little bit much. This is okay. I think that's clear and that works. But this, yeah, I think it's too much. So one of the other things I try to do is I use Google Calculator a lot. And so it's like if you do 10x, like Google will support 10 and a half plus 1/2, and it'll work that out. And then you can look at how it parses things. So that's pretty cool. But if you try to do like 10 over sine x, it's just going to barf and do this kind of thing. I guess it treats it like this. But if you do, I wonder what would happen if you do 5. Will it? Okay. Oh, yes. Okay. So interesting. So it parses to 105. So it actually eats the space and combines. So it's like kind of tricky to parse some of these things. But yeah, I don't think the fractional part should be able to include arbitrary sub-expressions for the purpose of like fractional numbers. I think for the purpose of general expressions, yes. So like that. So, and I think, well, okay, I mean, this is a little bit of a parsing question too, because here it doesn't know that it's x times sine x. It just can't parse that through. Like this is a different parse than this. So it should be able to do this, which it does. So 10 sine x works. But, you know, there's a limit to how compact you can make these things without running into ambiguity, unfortunately. It's interesting because, this does work. Okay, yeah, so actually I made this work. So if you put spaces, so this is another weird thing. In math, typically, if you write things with spaces, there's an implicit multiply between kind of numbers and things. Except if you do 10 and a half, there's an implicit addition here. And so in order to simplify the parsing of things, I actually pick these things up at the parsing level. And if I notice that there's a number followed by a number, and if there's a number followed by a number and that number then is followed by a divide, I combine all those things into a fraction. But if it's a number followed by a number, it's actually an error because it's like, this is not, even in math, I think this is not considered legit. like this is not an implicit multiply, because implicit multiplies are only between like numerals and pronumerals, I think is the term. So yeah, so that's where we're at. So what I'd like to have happen is that instead of like unexpected token kind of things, when I say 10x, or I guess I replaced it to unknown variable because it is an unknown variable, I'd like it to just, yeah, exactly. Google's like, so the two things I look at is Google and Wolfram Alpha, which also, like, I'm actually curious, what does Wolfram Alpha parse this as? Interesting. So, okay, yeah, right. I remember looking at this. So Wolfram Alpha will parse spaces as an implicit multiply between numbers, which is interesting. And so I wonder what happens if you just type 10.5. Yeah, assuming, is he referring to math? Yeah, it's going to say it's that. But if you do 10 and 1 over 5, it, see that? So if you give it a fraction, it does an implicit add. But if you don't give it a fraction, it does an implicit multiply. Yeah, welcome to calculators. So the part that implements this is here. Where's the number bit? Number, yeah, there we go. So we advance. This is like parsing the number bits. If we get a token that's a number, we advance one further token. If it's a number and it's an integer, then we try to do a fraction combine. And so we advance the token again and look for a forward slash. If we find a forward slash, then we do the fraction combine on those by getting the next integer again. And if we don't, if it's a digit, then we do a digit combine. Oh, I forgot. Oh my God, that's right. So, okay, check this out. So this, oh, this used to work. It used to be that this ended up being 101 or 11 or something. Did you? I don't know what happened. Oh, so now we get an expected number. Interesting. I have to look into it. Yeah, so the reason why everybody over parenthesizes is precisely because of this stuff. Yeah, like, because no one knows, and all the calculators are different. So, but since my calculator, I'll know what it is. So I just want to write this 4/18 or something. Like, I want to be able to write this kind of stuff and have it convert the feet to inches and vice versa. Like, I just want to type that. So that's my goal. That's my beacon that is drawing me to this in terms of numbers. And I want it to be able to work with units. And so the first step is to, whenever you encounter unknown variables, instead of just simply dumping out, we need to print it back out. So like the response from this should just be the parts that I couldn't simplify. And that is a tricky thing. And that is because of the way the evaluator works. So let's look first at how it's printed. That's the plot. Okay, display result. Okay, so here's the actual part that does the calculation. So we create a calculator, we run the AST that we parsed. Here's like where it's parsing the message. And then if there's no errors, we check for plots. If there's plots, we plot them. Otherwise, we display the result. And the display result is taking values. And the values are a thing that the eval system pops out, which might be a variety of things. So values might be numbers, they might be strings, they might be variables, they might be functions, and it might be a list, because sometimes you can return multiple things. Like you can do f of x returns 3, 4, and then you call, well, you don't even need f of x, just f of anything. If you do that, you actually get a list. And so this actually shows the contents of the stack. So it's saying 3, 4. And in the print, it would look something like this. So it would print this out. So a value might come with a next item, and also maybe children, but also, yeah, so anyway. So for this case, we needed to return, we'll need it to return, so instead of unknown variable, can we just push, what happens if we just push the value? Not nil value, can we make a variable value? Is that crazy? I don't know if the evaluator is going to barf, because it might say like, oh, there's still values on the stack, but I don't know what will happen actually. So what if I make a variable value with symbol? What is that going to do? Is that going to crash out? No. No. Oh, variable. Okay. So I just left a variable on the stack. And what if I do 10 times x? Nil. Okay, because it doesn't know how to multiply by that. Okay, but if I just do x, it gives me a variable. So why doesn't it print it? Oh, because it probably doesn't know how to print variables. Okay. So it's coming into here saying I have, okay, right, because it only knows how to print numbers. Okay, fine. Let's print variables. What do we have in there? Variable dot stir. Okay, so what, I always forget the syntax for this thing. What's the freaking syntax for that? This thing. I never remember where the star goes. Okay, so values dot variable dot len. Why is the len lowercase? Who knows? So what happens if I do that? Hey, look at that. Response x. Shabam. Okay, so now if we type x, it will respond as x. But if I type 10x, it's still confused, because 10 times nil is going to be, well, it's going to probably evaluate the multiply and say that's a nil. So really, we can't return, we really can't return values. We have to return the whole tree, because in the worst case, you might have to just straight up print exactly like this. Like you might need to just straight up print the parse tree. That's annoying. Okay, so what happens? What's this thing working? I'm curious if the Twitch chat will work now on this thing. It's like super slow to verify. Okay, so if I have an operator, okay, so this is what evaluates the the multiply. So if there's a kid and then there's a other kid, so this ought to be I see. So I just actually changed this stuff over to a wrapped Naut representation, and now debugging sucks. So I think I need to at some point invest in like actual whatever NatVis or whatever it's called, so I can actually debug these things. Okay, so it has the kid and the sibling. So that means it got the two sides, and then it pushes the op instruction and then eval instruction on both of these. Okay, and then it will push those. And then it's gonna run again. And as it advances, it's gonna say, okay, I'm gonna eval one of them. Okay. It's gonna eval, the first one's gonna be a symbol. And it's gonna eval the symbol. And now we're gonna push the variable in. Okay. And then it's gonna eval the number, I believe. So it's gonna go in and it should find number. Yeah, and then it's gonna eval the number and push the value. Okay, and then it's gonna start to, so now it's got a value and a variable, which it can't deal with. And now when it goes around one more time, it's gonna do an operator, and it's gonna go to do operator. And it's gonna get the type, okay, and it's gonna say it's a binary operator, left-hand side, it's gonna pop the value off the stack, no problem, it's a number. Right-hand side, it's gonna try to pop the value. Okay. Right-hand side, it's gonna be a variable, right? Yeah, type variable, okay. And now it's saying, okay, if both sides are number and number, then I can essentially output back a number, but it can't because one of the sides is a variable, and then it just says arguments aren't numbers, and it borks out. So here I need to basically say, yeah, I need to return the tree back out here instead of actually doing the result. Yeah, so probably the correct thing is to not even treat this as an evaluator problem and instead treat this as a tree simplification problem. Oh, it's a big rewrite. I don't think it's gonna happen tonight. That's a pretty chunky rewrite. How are people doing out there? Yeah, I don't know if any of that made any sense, but it basically means that the way I'm evaluating stuff, like the way I'm evaluating stuff on the stacks right now is I've got all these, like I go, this thing I was just stepping through, it's a virtual machine which pushes values on, pushes operators on, and then takes the operators and tries to collapse them. And the reason you need that is because of recursion. So what I used to have a thing that would walk through the whole tree, like the abstract syntax tree, and then every time it saw an operator, if it saw two numbers underneath, it would just collapse them to one number, like do the multiplication, like 10 times 5, and it would replace it with 50. And that worked fine. And then I added functions. So then you had functions like, f of x is 10 times x, and then you could call f of 5, and it would say, okay, you have f of 5. I looked that up in the symbol table. Okay, I'm going to replace that with 10 times x. I'm going to replace the argument with x, and it would like substitute the argument and then collapse the tree, and it would ultimately replace f of 5 with 50. But if you do something wacky like that, it doesn't work because I just had it recursively evaluate things and recursively try to substitute things, and the recursion would just make it bork out. So instead, I had to write a software stack rather than using like the actual C library stack. And because of that, I switched everything to this stack machine thing, so which could step one at a time. And then now we get error out of memory because it just like tries to do 1,000 deep stack or something. And then if you run it, if you just keep going, it gives up. So because we can't detect if something will terminate necessarily, halting problem and all that, right now it just shouldn't crash. But because I changed that, I also lost the ability to do tree substitutions. So maybe what needs to happen is that I just should not be returning values at this stage. I should be using the same kind of substitutionary thing. But put nodes back on the stack. I don't like it. I don't like it. Yeah, I think that's the right thing. You're supposed to return another stack, but yeah, so I think the correct way to phrase this is that, like in this case, I think before I do this evaluation, which tries to do the final substitution, it needs to do like effectively what would be a constant folding operation, like in compiler parlance, I think, where you figure out all your compile time things and fold those. And so then the result of something like this would simply be that nothing happened in the constant folding, and then you run the evaluator on it and it fails to replace pieces further, even with the functions, and then it returns a tree. So I think we just need to be returning trees, not values. I think that's the thing. Because as soon as we have recursion, we have to do stacks again anyway. So it can't just be total simplification. It's just wherever I'm returning values on the stack, I've got to return trees. Dang, that sucks. Okay. Yeah. I think you need a tree sweep and then a stack sweep. But then, like, if you just do a pure tree sweep, like if I refuse to evaluate anything that's recursive, how would it handle like what if I have a factorial call here, which is totally fixed function that should, or like I don't know what factorial 10 is, but like factorial 3 is 6, right? So this should return 60x. So then even the non-tree sweep, the one that does the stacks, I think also has to like be okay with indeterminate variables too. So maybe the values come out on the stack. Okay, so what's happening here is it's saying, okay, I'm trying to eval an operator. It's binary. I have both kids. And then it gets to the actual simplification of the operator, and it says, okay, if I have left and right, I simply do the actual thing. But if they aren't numbers, I need to push something back on the stack that isn't a number, but like an operator again, but don't evaluate it. You need the tree sweep to be able to simplify based on the commutativity and associativity. Yeah, so that already happens in the parse. So the associativity and commutativity and oh, I see what you mean, like in terms of the properties. Yeah, so that's right. So you need to be able to simplify at the tree level based on those things. But I guess what I'm saying is you're also going to need to simplify by running as well, because we want to be able to run as much of the code effectively at compile time. Like it actually is all at compile time really, because there's no, well, the only runtime that happens is if you have like f of x is x squared, like that, or like that. This defines a function. And like if you do that here, you can see, so what it leaves on the stack is a function. And the calculator knows that when it's sort of time to display results, basically it goes in here and it says, okay, how many values do I have? Let's check my values and see any of the values are plots. And then if it finds a plot, if it finds a function value, then it ends up plotting it. If it doesn't find any functions, then it displays it, so like a number. So this is a kind of function where there are arguments that are sort of runtime effectively, because there's nothing you can do at sort of evaluation time to simplify this. But by the time you get to the outer loop, the calculator sort of host app says, okay, we've got a function in here. How do we display it? We're going to display by plotting it. And so the way it does the plot is plot. So plot ends up having to do this is called plot one in, plot out, because there's different, like this is a one-dimensional function to a one-dimensional functions. And so the way it works is it's similar like a Lua VM, if you've tried interfacing with Lua. So Lua lets you push a value onto the stack and then call the function, which is at like position -1 on the stack. So right now a function is at the top of the stack. If you push something on top, which is like the argument, you call the function and that pops off the value. I think in Lua it also pops the function off, but I keep the function. I think it's RPN. I think it's well, trying to remember. It doesn't, so it's not like it converts it to RPN syntax and then evaluates it. It's more that the function just gets its arguments passed in or pushed on top in the reverse order, and then you call, and then you take them off the stack. Yeah, the mental model is the same. So I don't like RPN calculators because I just want to do 1 + 3 + 8, so I don't know. But internally, that's definitely the right thing. It's definitely the right way to like evaluate stuff. So yeah, what are we doing here? I guess we're doing the function thing. So basically what I was saying is that the compilation step leaves a function on the stack, and then the calculator printer basically goes, okay, we've got a function. So we're going to have to pass it a bunch of different arguments. pcalc. Let's see, pcalc. Oops. That's the other one. Go. Oh, yeah, I think I've seen this. Yeah, my friend likes this. Is there a read manual? Let's see. Yeah. Yeah, and is this the one that also has like the seriously good math library inside? Like the, what is it? The Intel decimal floating point or something? Yeah, I'm sure Emacs has like all this stuff. Of course. Actually Discord does too now, but Discord is not quite as sexy. Like Discord won't do certain things. It won't do like parentheses and things. Well, it'll do like some parentheses, but it doesn't have like sine, cosine, obviously. Emacs can't define variables. So I don't think anyway. Oh, and Emacs is RPN. Yeah, it makes sense that Emacs would be RPN because like it's how they are. Yeah, so I need to think about how to break this down into passes, and it might be for another day so I can spend some hammock time on it. But basically, this is as far as it simplifies, and then you end up with a function on the stack, and then it's up for the calculator to print it. So this is like effectively the runtime of the program. And so there's also the effectively something like compile time. So if you do 10 times 3, here, this should get folded at compile time. So effectively, at some point, the thing that makes it to the calculator should actually be that. So that needs to do a fold. But it also needs to handle something like this, where the y is in, or like, let's call it like meters or something, where the y is indeterminate. So it also needs to leave this alone, which means plotting a function with an indeterminate number should also be, well, that doesn't really work, but potentially. But also it needs to do something like this. So if it does factorial 3, it should replace that with 6 and then figure out 6 times 30. And so then you can get 180. So there should be something that's able to take this and ultimately output this. And in fact, yeah. Yeah. So it needs to be able to run arbitrary code at compile time. So it does need to use the evaluator. And because it could also have something like this, it means that some instances have to be able to run at compile time, and some instances need to be deferred until effect, so they need to be held as trees. Dang, writing a UI system might be simpler. Okay. It's also programmable, you can define variables. Dang. Now I'm curious. What can Emacs calculator do? Oh my God, look at that. I'm offering symbolic algebra matrices unit conversion, RPN algebraic graphing, financial functions. Of course, it's acting like a poor man's mathematics. So I was wondering, has anyone written like this? And of course, it's Emacs. So I've already been scooped by Emacs. I should probably read this and get depressed and just abandon the project. You can just do everything. Dang. All right. You could do the functional thing where it automatically evaluates to a function that takes a function and are occurring, but maybe that's just more complicated. I think it does have to do something like that, but I don't know if I have to call it current Emacs as a native mobile version. No. Oh God. So like you just wrap Emacs, like what kind of like madness would it be to run like Emacs in WebAssembly and wrap it in Electron and then just like ship it on all platforms and then just rip out the part that's the calculator and just ship that? And the GNU people just eat me alive. Just wrap it till it runs everywhere. How does it do symbolic math? That's wild, dude. Oh my God, look, units conversion manages quantities with units e.g. 43 miles an hour, and provides conversion routines including time. I need that YC money. Can Emacs calculator do complex unit conversions? Yes, of course it can. Yes, Emacs calc. Okay, so it knows the units like speed of light, complex conversion, convert 3 cubic meters to gallons. Jesus. Define your own units, of course, of course. Using math additional units variables. Well, it's a good thing I'm just doing this for practice, because ain't no one need this if they got Emacs. But then again, getting people to install Emacs is non-trivial as well. I might have to read this later. Oh my God. I mean, I feel like I'm effectively writing a subset of Lisp, right? Like that's the whole meme that every language has some broken version of Lisp in it. This is definitely the case with the Naut language. I just need to find one thing it can't do to regain my motivation. It's going to be like, can't do fractions. Can Emacs calculator do can combine fractions? Come on. Can I input fractions? Colon notation. But see, that's not pretty. 1:2 for 1/2. No good. Gotta write our own. All right, back to it. Not pretty enough. But we do need to return a whole tree, and it's probably some kind of currying thing. Okay, so in this case, does it make sense? And okay, and we can't, so if factorial is defined as like, you know, x times fact x minus 1, right? Standard like recursive definition. Well, we need like if statements and all that, but whatever. Maybe we just return 0 at 0. We don't want this to expand to some, like we don't want it to expand to x times x minus 1. Well, we can't. X minus 1 times x minus 2, like, because it doesn't know when to stop. So there's no replacement that can be done here, so it has to be kept as that. But if you have another function, which is like area x, right? And area x is like the area of a circle, so it's like 2 times pi r squared, or is it pi r squared? What am I saying? Pi r squared. This one ought to be replaced, right? So you do want this to be like that, because then you can be like, oh, there's another x squared here, there's a x squared here, so you should be able to combine these two x squareds. So factorial functions cannot be expanded at compile time, can be expanded at compile time, but these can be evaluated at compile time if constant args. So sort of depends on how the args flow. Emacs propaganda. You reckon expanding area doesn't make sense? Don't you want to combine these two things? Wouldn't you get like a nice, you know, you have 10 times 3, so you'd have, wouldn't it be good? You get 30, right? Fact comes out, it's a 6, becomes 180, right? Then you get that one, and then pi comes out, so it's like maybe even flatten pi, and then you have that, right? And it's x2 times x, and then x squared times x squared, right? So you get x to the fourth. Look at that. And then these can combine to like whatever that combines to. Is that a bad idea? Because in a more complicated case, like, wouldn't you want, one of the things I do sometimes is I have like a big formula that I wrote, and I'd like to get like a simplified version of that formula. So this seems like it would be good because these, effectively this kind of thing is a formula, you know, like an alias for a formula, right? Imagine a super complicated one like area somewhere polygon. I don't know. Maybe that would be good though. Wouldn't that be good? Isn't that like, so I don't know about you guys, but one of the things I use Wolfram Mathematica for is I'll sometimes have like a really long expression and then I ask it to simplify it, and sometimes I give it like really hairy stuff and it comes back with a nice compact result. I do want to make a symbolic algebra. Yeah, that's where I'm headed. Yeah. That's why I was, you know, a bit despondent that Emacs already got there, but I absolutely want a symbolic system, because that's one of, so basically, yeah, I guess another way of phrasing it is I'm doing units by way of symbolic manipulation because I think units are sort of like a subset of symbolic manipulation, and symbolic manipulation is useful anyway. So let's just do that. How hard can it be? Right? Poor man's Mathematica sounds right. Yeah, it is for evaluation of simple graphs and math, but I like this idea that like it's sort of this tiny little calculator, but all of a sudden it can do like symbolic math. I also kind of have this cutesy idea around solver syntax as well. So like if you have some kind of function like f of x is x squared plus 3x cubed or something, I want to be able to write like f of what equals 5, and I want that to evaluate to like basically the value, or if you put that to 0, then it should give you the roots. So I'd like it to also function as a solver. That's part of why I wrote the compilers, because I can do cute syntax. Otherwise I have to, you know, in whatever like Mathematica, you have to type like solve f x on range 0 to 18 or whatever. And you're like, that's gross. I want to write f of what equals 10 or f of what equals 0. So you need a parser for that. Algebraically or numerically. The solver would be numeric, but if you have a symbolic system, maybe it can do some of it algebraically. Yeah, and I think numerically is straightforward. And so one of the things I was also going to use is there's this Intel decimal floating point math library. If you've seen this, it's like basically a software floating point, but it's in decimal. So instead of binary floating point, it's decimal floating point, meaning that, you know, like in normal floating point, if I write 0.1, that's actually represented as like 0.00012 or something, because it's binary. But in the Intel library, it would actually be exactly 0.1, because it's decimal floating point instead of binary floating point. So that solves all of those problems. The symbolic simplification solves problems that, have you seen like the Google calculator? Or is it Android? Android did this thing where the Android calculator is able to do like some really crazy stuff. because they kind of like, basically they took like giant numbers and they made it work. Yeah, like this kind of stuff. So if you do it on iOS, it just gives up because of floating point, but Google's calculator can do it because they symbolically subtract the right side from the left side, among other things. So I want to do that. If you went all numerics, then you could simplify. Yeah, I don't want to go all numerics. Yeah. Yeah, because of, partly like this, because, so one way of doing it is to do like a software infinite precision library, like Shuchuk's. Adaptive floating point precision. So there's this guy, Shuchuk at Berkeley, who wrote this for triangle tests. Where is it? I don't think he probably doesn't show. Yeah, fast, robust predicates for, like, it turns out if you do computational geometry and you do these like tests of circles and lines, you need like super high precision math to do it well. Otherwise your like triangulation gets messed up. So he wrote this infinite precision library that everybody uses, or some people use, but it's got a bad, like, a really restrictive license. So there's like a BSD version. Anyway, you can go this route and then you get like unlimited precision. But the problem with that is that, well, just because you have unlimited precision, you still have to stop somewhere. Otherwise you just keep printing forever and you can get in situations where it just keeps going. So I don't think you want to do that. So I think like the Intel library is better because it's got like 34 digits of decimal precision, which is like more than anything, any constant that we know of kind of thing, because it's a floating point thing. So you do that for when you fail, and then you do this kind of thing for simplify. So basically you try to simplify as much as you can. You simplify fractions. You keep fractions as rational so that you're able to do like, 1 over pi times pi over 1 or whatever, and then have that cancel out. You do all the, all the rationals correctly. You do all the numeric simplification, and then hopefully by the end, whatever you're left with is just irrational or large decimal numbers or constants. And then you run that remaining thing through the Intel library, and then you get something like the best result you can probably get. So that's the goal. That's the goal. This is a big project for a small little thing. So I guess what I need to do for next time is I need to start looking into how do I start passing trees around my evaluator and putting trees on the stack, and then also marking some trees, marking some things as non-expandable because I don't have the variables defined to expand them, and some things to expand even though I don't have, so like I need to be able to say this one you shouldn't expand because it's recursive and I'll never do it, but this one is non-recursive, which I can analyze from the call graph. Say, okay, this thing doesn't call itself, it doesn't call anyone else that calls it, all that stuff. I can expand this one, don't expand this one, run this one because it has an argument, even though it's recursive, hope it succeeds. If it out of memories, then I don't know what. And then, and then I guess the last one to think about is like area of 3. Yeah, that one is also, you just expand. So I need to detect by the signature what to do with it, and then expand the tree. And then once I have the whole tree, then I run the simplifier over the tree where I can fold the numbers together for now just numerically, and then leave the variables to print. Okay. Damn, maybe I should just work on UI on stream. Otherwise, it's just going to be talking about numbers. All right. Well, I'm going to go. I got to go for tonight, but thank you all for joining, and join the Discord if you want to chat more about it. I think it's fun, and there's a lot of fun compiler stuff inside to play with. And who knows, maybe I'll just convert this to me working on UI on stream, because I have an immediate mode library that I wrote, and I need to replace. Right now this is running on top of IMGUI, but that has some downsides. Like, I'll show you. When I resize things, it doesn't, well, I mean, I could probably figure it out, but I'm just kind of tired of messing with it. But Wukash asked me to like add a thing to enlarge and change the font, but I have to like figure out from my GUI how big the fonts are and split the windows, and then this is too big. So I also want to add like dragging and buttons to the graphs, which is a little bit tricky. And so rather than making custom widgets, I also want, you know, syntax highlighting. So I want to replace the text widget anyway, because I want to highlight the variables. So I want to rewrite that. So maybe it's easier on the stream to do that stuff because it's less researchy and more just type stuff up. And then maybe sidebar into the researchy calculator stuff when there's more kind of concrete work. Yeah. But anyway, glad y'all enjoyed it. Take care.